The third video on vector valued functions. This is number 3, straight lines and line segments. Before we kick off with that, we're dealing just with 2D in this video. I want to look at this first here. For a vector function r of t equals x of ti plus y of tj, the domain of the Cartesian relation or function that comes from that is given by the range of x of t. The range of the Cartesian relationship is given by the range of y of t. So for an example, if we have 1 minus cos ti plus sine tj for our r of t, we need to generate equations 3 and 4, which were shown in previous videos. So we need to then, for the domain of the Cartesian relationship, we need to find the range of this, which is all the possible values for x. Now cos of t itself can be between -1 and 1. So if we have in x equals 1 minus -1 at the lower end for t, that's 2. We could also have at the upper end 1 minus +1, which is 0. So it can include those values as well. So basically that would be as an interval 0 to 2 inclusive. Okay, so that is the domain of, because it's the range of x of t, it's the domain for the Cartesian relationship. Okay, so for the second statement, for the range of the Cartesian relationship is the range of y of t, so we're looking at all possible values there. Well, sine of t can be anything from -1 to 1, so that's directly equal to y, so it includes everything from -1 to 1, so that thing is the range of the Cartesian relationship. Okay, so that's a prelude to the rest of the video. Okay, so here's an example for the main goal of the video. Find the Cartesian equation for each of the following, state the domain and range, then sketch the graph. So for the first one in part A there, remember in general we've got points x and y such that xi plus yj, x equals cos squared t, and y equals sine squared t. So what we have then is, if y is sine squared t, that using the Pythagorean identity, that's the same as 1 minus cos squared t, and that's equal to x. So we have y equals 1 minus x. We've got to look at the domain and range because that informs our sketch that we're about to do. Okay. Now since you know that cos has a value between -1 and 1, well, cos squared has a value between 0 and 1 inclusive, and sine squared t has a value between 0 and 1. So this informs our domain and range. The domain of the relation will be 0 to 1 inclusive, and the range will be 0 to 1 inclusive, because we see, if we go back to the actual given equation there, we can see where cos squared and x and y are link. Okay, so to sketch it, we would sketch the graph of 1 minus x, which is -1 plus -x plus 1, I should say, and that is limited by the domain and the range. So it's a straight line that goes down like that, and we have 0, 1 there, and we have the point 1, 0 there inclusive. So the dot is filled in. Okay. Okay, last one. We have r of t is ti plus 1 minus tj. We have to do the same with that. This one's a bit quicker. So x equals t, y equals 1 minus t. So we can say y is 1 minus x. And so we've got a graph here. T is any real number, by the way. So like it's the same graph as last time, but there's no limit. It's not a line segment, it's a line. Remember the difference between a line and a line segment? The first one is a line segment, this one's a line, and it goes through the same points, but it goes continually. If you like, you can put little arrows on the end.